walk through here, and we'll walk out this other building. If you notice, there's a head in this room, and it keeps the room cool. This room has to be cooled all the time. Thank you for your. That's for
Installed 17 kilowatts on my house. We spoke on the phone and he said,
still have what?
Big system. I mean,
For the ones we finance, it's not. Come on.
That's gonna be different.
oh, because I guess it's just the two.
VRS. 144 ABTU that handles this space. And then I think the one's doing this space. The lights are going out. Saying it's time to close. Something very unusual you'll probably notice about the walls. There's no plywood on the walls. There's plywood in the sills, but there's no plywood on the walls. This building is purely metal. The construction of the building is such that these metal girders hold up the whole building. None of the rest of this stuff is load bearing. None of these walls are load bearing. None of the internal walls are load bearing. It's a completely open span space. That's actually foam insulation. It's 6 inches thick, and there's 2 layers, and we alternate the gaps on the layers to reduce the amount of airflow between the layers. And then on top of that, there's actually a rubber membrane that's around the entire building. And the idea is it reduces air leakage. And then we went one step further. We wanted to see the performance of the building, so we actually took an AeroSeal and we went ahead and pressurized the building with the AeroSeal machine in here and vaporized some stuff that looks like Elmer's glue. And it went into every nook and cranny in the building and sealed it up and brought us down to less than 8 CFM for 75 Pascal. So if anyone knows anything about airflow, that's really good, that's really tight. And that's the reason why we need, like over here, we need these ERVs bringing in fresh air all the time to the building. Here, oh, there's one right there. There's an ERV.
John, are they on emergency power?
No,
So what happens?
they're on the solar system.
They're heat exchangers.
They're heat exchangers also, besides being fresh air. So they will, when the air paths change, they'll either heat or cool depending on what the inside-outside air temperature is, reducing the energy consumption that much further. We do have to provide some electric heat when it gets really cold out. There's not enough temperature exchange in the heat exchanger. So to prevent super cold air from hitting the occupied spaces of the building, we provide a small amount of electric heat.
What's under the floor?
Very good question. Very good question. There is foam 8 feet in from the exterior. There is nothing under this floor, and that's on purpose. We found out that this building is heat load dominant. We ran all of our energy models, and we did run models with foam all the way through underneath the bottom of the floor. And what we found out was that the building, as designed as an office building, would consume less energy if the center of the building was coupled to the ground, because it cools more months out of the year than it heats. So that's something we've been across the country at different events asked to come and speak about, because that's questioning the current methodology that's used out there. Right now, the current methodology is you put a bathtub together of foam and you pour your concrete in it. It's something we've been out saying, hey, that may not be, you need to do an energy model. It may not be right for your building.
What about the ceiling?
The ceiling, in here, in the whole building, there's 3 layers of insulation in the ceiling, and it's R49. So that's the assembly. When I talk about insulation, like here, there's 1 layer missing. There's only 2 layers here, but there's 3 layers in the rest of the building. That assembly is R48. So when I'm talking about, I'm not talking about just adding the value of the thermal resistance. I'm talking about this takes those metal studs into account. This takes everything into account, the air leakage, and gives you that assembled value for energy efficiency.
So how many layers you have up there?
3.
3.
3 and 3. So just different makeup. Here it's all a fibrous type insulation. Here it's foam, and then the last layer is fiberglass.
Did you
How are you
alternate over
bridging for
the same
beams?
as you did on the wall?
Same thing, yes.
How are you handling the bridging with the beams? The ceiling beams, do you have an insulation layer on top of them?
We have insulation on top of the ceiling beams. There is some leakage in the building around the bottom of the beams. We put a frost skirt in place, but just the way the building was designed, we weren't able to keep everything warm all the time. And that was the weak point, was the posts for the steel building. But there is a frost skirt around them to help minimize that heat transfer.
Hey, John, what do you use this room for?
What do we use this room for? Storage.
Super efficient storage though, right?
Roller dirt.
Actually,
It's so
there
efficient
are
that you can't even see it.
there are 4 units in this space, up there and 3 along the wall in this space. They keep this space, no matter how cold it is outside, they keep this space comfortable year round, no matter how hot or cold it is outside. So even though we're not using this space, we're actually heating and cooling this space to 65 degrees. And we're doing it with a minimal amount of equipment. It stays there, mostly it stays there on its own. There's some solar thermal panels, the same kind that's on the roof. So all the water in this building is heated by solar thermal. So besides PV, if you look at the roof real close, you see a cutout, and in that cutout you see the solar thermal panels. They were actually no cost to us because they came off a building in Astoria, New York. We have a for-profit subsidiary called Sustainable Energy Systems, and they had been leasing out solar thermal panels. And these panels were up for 2 years, and they ended up getting taken off. And we were the benefactor of the panels.
Is there hot water storage someplace?
Yes, there is. I'll show you that.
So you're saying you have extra panels?
Yeah, I've got extra panels.
Oh,
Interesting?
hey, I see you standing there.
Did you look at using the floor for heat sink?
Just for cooling the space. These 2 units out here are the Mitsubishi units, and they're responsible for all the heating and cooling that goes on in this building. So those are the little hail shrouds that are on them to keep it from getting damaged if we have any hail. You'll see our lot is a mess. It is, only the front of the lot is mowed. And then every September, contractor comes through and cuts it all down to 6 inches. And we go back to letting it grow again. So it was a design choice to actually only take and mow part of the lot.
Now, have you planted that as a meadow, or
We've-
it's whatever was there?
No, we planted it as a wildflower meadow,
Okay.
but other plants have been stronger and taken over for it.
Weeds are much more aggressive.
I see this.
Yeah.
We do have some good stuff coming
I
up.
see, I see some you could do.
Yeah, there's some.
Yeah, there's a rain garden out there
Do you have
too.
a problem with
Okay.
stilt grass?
I haven't seen stilt grass yet. Sweet woodruff, crown vetch. We got Japanese knotweed in the corner. It's that corner, right? I mean, you see it's just flanking that whole bottom corner.
We maintain the Appalachian Trail, and
Yes.
the section that we particularly take care of
Their ground
is
source
along the
there.
Schuylkill River and the
Yeah.
knotweed
Yeah.
from the trail to the river.
No, there was
It's
enough
so
issues with the ground here with,
Yeah, you can't see the river.
And that's
When we
what,
cut it down, it just comes right back.
and that's one of the things that is like.
the ground was
kind of
chemically
here and hasn't
contaminated
been
with arsenic.
as aggressive on it
Because it used to be an apple orchard.
So
So we had to, first thing we had to do was clear the ground and then take care of remediating the ground before we do any building.
So did that affect the teeter totter method of ground source versus air source?
No, the ground source was definitely more expensive. There was no question about that. But the air source did what we needed it to do. It was good to -5 or -10 degrees, which means we didn't need any backup heat,
And supposedly, it'll do the same thing.
and it would have cooled the rest of the year. So it really doesn't.
Really curious to see how that works.
I don't know how much more of an advantage a ground source heat pump. That was part of that energy efficiency. Go till you get to the point and then
It's
stop.
gonna be a heck of a thing.
We didn't do everything super energy efficient. We did some things that were very cost effective to do.
So there's no resistance back up to that.
No resistance backup.
No trouble in the winter times keeping up.
No, not even with some of the cold spells we had this winter. And this building will drift. We've tested it. We've shut it off just to test it. We've shut off all the heating and cooling for 3 days and came back in and the building was still comfortable. Now we get -20. I don't know what to tell you.
Not right away.
Is this the one you were looking at, or are you building something different?
It's nice to get out, isn't it?
Even the one I have at home, I have air source heat pumps with 4 or 5 heads on each unit. They're guaranteed down to -10. So it's becoming more common, I guess you could say.
We have some train units that are ground-based, but they lose efficiency fast below.
Well, these train units take care of, train takes care of Mitsubishi.
I saw that.
I knew that, Russ, when we first started putting these units on a regular service schedule, because train didn't know what to do.
Yeah, we come up against that a lot in the business.
Ground concrete.
What?
Ground concrete, right?
Yep, ground concrete. It was supposed to be with glass beads in it,
Yeah.
and the contractor forgot to throw the glass beads in.
It's awesome.
So it had to have it ground instead. And that's why it looks funny, because they started building and I came in and said,
Lots of people.
there's no sparkles on the concrete. And I said, oh, we can grind it for you. And then they ground it after the walls were already in.
Yeah.
Out there, the space that you're seeing, that you've already been enjoying, that space is used by, eventually if there's additional tenants in the building, that space will be used by them. It's designed to be used by the whole building. Same thing as that classroom. It's designed to be used by the whole building, not just us. Obviously, you want to maximize space utilization, and we just don't have that many events. We have maybe 10 events a month or something. So we don't have that many where it utilizes that space all the time. Behind you is a nice little area for staff. Sometimes they'll come over with their laptops or whatever and be in a small group. And they'll be working together. That's all reclaimed lumber. That's up on the wall. It's not apple wood. We did save some apple wood, and we've got a store of apple wood about this high that's been to the kiln and been dried and everything. But it was very difficult. The trees that we were taking down were so dead they couldn't take the wood out of them.
John, there's a question. What's the purpose of the wood? Is it just decorative?
Warms the space some.
Warms the
Some
space?
acoustics to it.
Yeah.
Gotcha.
If a truck drives by on the street out here, do you hear it?
Do we hear it?
Yes. Would you
I
hear
do in my office sometimes, but not all the time. It really depends on the truck. We get a ton of them because that UNFI warehouse that's down the street, the sign they have is facing the wrong direction. So the trucks just blow by, and their address is 4250 Independence Drive East.
Oh.
Ours is 4250 Independence Drive.
Yeah.
So they come here. We've lost stop signs. We've lost all kinds of stuff. They've torn up our grass and everything, turning around in here. It's been something else.
But generally, it's really quiet in this building, isn't it?
Very quiet, yes.
Put a sign up that says west is down the street.
Where are the windows at?
They're all dual pane windows.
Just dual pane.
Just dual pane. It didn't make financial sense to go triple pane.
Do they open and come back?
Yes, that's a good question. All the windows open in the building, and each one has a switch on it. So if, like, you go in my office and you open the window, it automatically turns the heating and cooling off in my office. But it was designed to be a building that staff members could open the windows and enjoy outside those months of the year when it's enjoyable. So it was something that we could provide to staff instead of just being sealed up in a building. And it's amazing the number of them that use it. Double.
Do you know what the U is for it? Is it like 2 or 3, 4?
I don't know off the top of my head. If I can find a set of keys, I'll open that door. That's where the solar thermal tank is. The only thing in there are two water tanks and a fresh water supply from LCA. This is just the rest of the space. These cubicles, they may look nice, but these cubicles are actually used cubicles that the contractor that provided them refreshed, recovered, and then came in and did. So it provides a nice place for staff. It's not real high. In Sally's office over there, the accountant's office, Sally will walk in her office, so you know.
Look at my office.
If you want to look in there, the ceiling, now that's the only office or workspace in the building that does not have direct sunlight. But there is direct sunlight above it in the clear story windows. So we actually put that office, and during the day it helps bring in fresh sunlight to that office space.
Oh, yeah. Interesting. You should get a window.
Everyone works on Monday, and then some people work on Tuesday, some people work on Wednesday. Everyone works again on Thursday, and then there's only people to answer the phones in the office on Friday. So we're still working a hybrid schedule. Seems to be popular anyway. Well, you can come over and take a look over here. Just another kitchen and a small conference room. and then another ERB. Yes, it is a metal acoustical ceiling. Yeah, and it's actually got, the acoustical ceiling has insulation in it, but we don't count it. That was just something we put up towards the end of the project. And all these lights are obviously LED. Any questions about the building? I mean, that was a quick and dirty tour.
Humidity control also?
Yes, they do. Yes, they do. I gotta double check that. Yes, they do.
You mentioned the,
To add two-dimensional art to the wall?
Two-dimensional art?
To the wall?
No, that art over that we added over there was the, that was our big stretch at adding art. We wanted to maintain a minimalist environment in the office.
I didn't want to.
I have a question. Overall, did you save money or did you spend more money with design?
The design was actually a little more, but we cut a big break on it because the architect screwed up. So there was some money that came back on that. We also did our contract in a different way. Instead of us going out and letting a contract with an architect and a bunch of engineers, and then letting a contract with the contractor, and then one's providing specifications to the other one, we went out to the contractor and said, here, we've got $5 million. These are the requirements for this building. If you want to take on the project, and their contractors bid on it for less than what we were offering, then you go ahead and take that on. But they had to hire the architect and the engineers. So if there was a problem like these windows during construction, they found out the windows were too heavy for the sills and they had to reinforce them with plywood, wasn't my problem. I didn't have to say, oh, the architect didn't spec it over here, oh, change order. No, there was no change order.
Is it design build or not?
Design build, yeah.
Wow.
T.N. Ward, and then, can't think of the architect from up in New York. Ashley McGraw from up in New York. They did a really good job. They do a lot of net zero buildings, and they knew things that were smart to do and not so smart to do. And they were challenged by this building at getting it done in budget, but it led to a lot of speaking engagements. In fact, I was just with one of the principal architects in Denver. We were talking about this building, and this building's been occupied for 2.5 years now, I think. 2.5 going on 3. So they're still talking about the building. And to me, everyone should be building net zero. It should be nothing special.
What was your cost per square foot?
When they factored everything in and out, it was 3.25, I think.
John, could you talk a little bit about the solar panels, their efficiency?
I don't know.
How much electricity you're selling back to them?
I know that from May, when the utility credited our bill, until now, we've generated 64 megawatt hours of excess energy just across the summer. And we'll carry that through and obviously generate more all the way through the winter.
The balancing that you spoke of okay, here's efficiency, here's what we can generate and so forth, and the modeling that went into that, was that part of the basic contracting process that you did?
We came to them with the concept of doing the teeter-totter, of doing the balancing. And then it was up to them to work with the engineers to do that balancing. We also came with some energy models. We had energy modeled this building and similar design buildings. We had energy modeled those, so we brought those to the table. and said, here's what we've seen in energy designs. Here's what we see works, here's what we see doesn't. And we ran dozens of iterations from different equipment.
So you had a big asset coming in with those models then. Somebody who's building something like this from scratch and doesn't have such a thing that would be a major additional effort and cost.
I believe so. It depends on their engineering firm. If their engineering firm is down to a concise design and can do the energy model and run a couple different iterations, because once you have the model, it's pretty straightforward to make changes to the model. It doesn't cost a lot more to make changes. It's the design of the initial model is where all the cost is.
So you did a preliminary design, created a model, and then went to the contractor?
Yeah.
How did you come up with a model?
We did a feasibility study a couple years prior to that with Revision Architects, and with working with them, we tested out the feasibility of this concept that we thought we were going to, go down the road with. And during that feasibility study, we came up with multiple models design that were both flow efficient, building use efficient, and energy efficient. And then there were some things like we met with landlords, and like, for example, one of the things they said to us is that you got to be able to slice your building like bread. No matter what you do, you got to be able to slice your building like bread. And we took that to mean means you need to move the facilities all over. So if one space is 5,000 and then 2 years later it's 2,500, you've got to be able to adjust the heating and cooling, and you've got to be able to adjust everything else. Even the doors out there are all adjustable, so that the demarcation lines inside the building can move back and forth, and you can maximize the usage of the space for however, who knows what it's going to be in 10 years. So that was an important concept, and that was also one of the reasons we went with a VRF system, was because we could put multiple units, size them for the space, and we weren't saddled with having a rooftop heating and cooling unit and then running ductwork, and then all of a sudden when you move the space, what do? Do you put the thermostat in one space and the other space is served by it, and then people complain? No, it just seemed easier that you could move the heads from the VRF system to where you needed to move them.
Do you recall any conservation or energy efficiency measures that didn't make the cut, that didn't pass the teeter-totter?
More insulation didn't. We found that more insulation was a point of diminishing return. We could have put more insulation on. It was like on the outside, we could have put another layer of foam and added 6 more inches of insulation. But when you did it with the energy model, it just didn't, the payback just wasn't there.
But you focused on air tightness.
Air tightness instead, yeah. We got more bang for our buck with air tightness than we did with insulation.
And what about energy storage? Do you have any batteries?
We have outside when you leave, you'll see there's a concrete pad on the ground with conduit run to it, and that's actually for battery storage.
We were all afraid to park on it. Yeah. We all looked at it.
Yeah. So that's good. But yeah, that's for battery storage. We're looking at lithium iron phosphate battery construction. We're leery of lithium ion batteries because of their thermal runaway issues. For heat.
Sometimes.
So we'll see what happens. We've been watching the price. We have a great relationship with a manufacturer that we've done a bunch of work with in the past. In fact, at one point we actually tried to buy them, but all of a sudden they got a big deal come in and they weren't interested any longer.
I think it's commendable, John, what you were talking about as far as how you are making this space either warm or cool. You have that capability, because those of us who have worked in larger offices or talk with people who work in larger offices, there's always that issue. who's bringing in the space heater because their spot's cold and that spot's hot because they didn't think about where the windows were and which way the windows were facing and this type of thing. So I think it's very interesting that that was thought through because it's a very big complaint in big offices.
I had that early in my career. I worked for a Fortune 100 company, and I was in a big cubicle farm, and no one was happy with the temperature. Yes.
Is there a reason for the excess solar capacity?
Yeah, when we fill that space, you know, we want to be 30% over what we think they're going to use. So there's the excess from us, the excess from the tenant space plus 30% more. What happens if we get a computer company comes in? You know, and they decide they're going to mine Bitcoin or something.
Grants with your energy models, did you go for any grants from utilities or anything like that? You made it more about just design construction.
We requested 0 grants, and when we found out the headache we'd have to go through to get a utility rebate, we just skipped the rebate. And the rebate wasn't going to be that much either. It was going to be, you know, $10,000, $20,000 on a $5 million building. All right, let's go back to the other room.
Can I ask a question?
Yeah.
With the fresh air intake that comes in all the time, what happened when we had that smoke pollution?
There's filters in the unit that take care of that. And if they didn't take care of it, we'd close down and send everyone home.
Do you have a way to measure the air quality in here?
No.
I think it's very interesting what you're saying about the smoke, because in our house, we have something similar, well, the same thing, the renew air, where we're bringing fresh air in, and we closed everything up. I love having windows open. We closed everything up, turned that renew air system on while we had the smoke, and we smelled nothing in our house, which was great, but yeah, it was able to filter it.
All right, let's go back over there before it's going to exceed the footprint we want to take up, and we were less concerned about the efficiency of the panels, because that also decreased the cost of the panels. So it was really about, you know, dollars per kilowatt hour.
So you use solar for domestic water?
What's your